Good morning and good afternoon, everyone. My name is Sonia, and I will be presenting the SIRGAS-CON network processing. And as a result of this processing and combination, we have SIRGAS products that are weekly and time series of coordinates. In the previous presentations today, we have heard about uh, some information related to antenna, some aspects related to reference stations, GNSS reference stations, and to atmospheric modeling. They are very important for network, GNSS network processing, mainly for these reference networks. And my presentation will be more concerned about results, GNSS results, and the final weekly combination that provides these weekly SIRGAS coordinates. As responsibilities of Working Group 1, we have the establishment and maintenance of the geocentric reference frame for the Americas and Caribbean region, for which the main objectives are to coordinate the implementation and maintenance of geocentric reference frame, coordinate activities at the data and analysis centers, develop the tools, applications, and technical guides, and training linked to the activities performed by Working Group 1. Here we have the structure of Working Group 1, which we develop all these tasks. At the top of this level, we have the president of working group, and followed by the coordination, network coordination. The main task is update information related to stations. So this is very important for we have a consistent results, and the coordination, analysis coordination that evaluate the results. Under this umbrella, we have data centers, processing centers, compilation centers, and a neutral atmosphere analysis center. And all these centers provide data or solutions, SIRGAS solutions. Data centers, we have a regional data center and national ones, more than 10, collaborating for this regional densification. We have 10 processing centers. Some are data centers as well, not only processing or operational centers, but they carry out different roles. Combination centers that provide the final weekly solution, and the neutral atmosphere analysis that provide atmospheric products from SIRGAS network. The products, as products, we have the combined tropospheric Xenipart lathes with hourly sampling rate, weekly station position aligned to IGS reference frame, coordinate time series, cumulative solutions, let's say multi-year solutions that provide the station velocities, time series, pulse, seismic functions. And velocity models, we have a series of VEMOS velocity model and SIRGAS in the SIRGAS region. SIRGAS reference network comprises about 500 continuous operating GNSS stations, which are weekly processed by 10 analysis centers. These weekly coordinates of each SIRGAS station are computed by 3 analysis centers. So for each week, we have three solutions for each station. Each analysis center delivers individual weekly loosely constrained solution for station positions in SINEX format to be combined in a unified weekly solution. The internal and external consistency of the weekly solutions is around 1 millimeter in horizontal components and 3 millimeter in the vertical components. Regarding the softwares that analysis center are using, we have Gamut Globe K from used by Argentina, Mexico, and Peru, and Bernie's software version 5.4 used by others analysis centers, including combination centers. Then in this case, they are using still version 5.2. The weekly solutions are important to maintain and ensure the SIRGAS reference frame accessibility to the global reference system at a regional and national level. For this high precision daily and weekly network solutions, it is necessary to apply IGS standards, guidelines, and products. So here I mentioned IGS satellite orbits, satellite clock offsets, and Earth orientation parameters that are precise products, IGS products. Absolute IGS antenna, it means phase center correction model, which is nowadays IGS 20. And the weekly station geocentric coordinates from IGS solutions, that is provide the global solution that which will be linked to this regional SIRGAS solution. Here we have the strategy and some characteristics of GNSS data processing. As basic observable, we have ionosphere-free linear combination, sample rate 30 seconds, and elevation cutoff angle 3 degrees. We apply Mark II antenna centricities according to the site logs, which is very important, keep this information up to date. Troposphere modeling, we have a priori zenith part delay, dry components, which is modeled using Vienna mapping function, and other atmospheric parameters are estimated in 1 hour interval within the network adjustment using Vienna map function as well. Horizontal gradient parameters are estimated to model azimuthal asymmetries. Phase ambiguities are solved applying 4 strategy, and the quasi-ionosphere free strategy solution, we apply ionosphere models from center of orbit determination Europe. And for tidal corrections for solid and permanent earth tides from years conventions, ocean tide loading reduced with FAST 2014b, atmospheric tide loading for S1 and S2 reduced with model Van Dam and Ray 2010, and the final day free normal equation are combined from this daily, are combined this 7 days a week by applying double difference strategy, ion free, to produce loosely constrained. It means that in this case, all station coordinates are constrained in 1 meter, providing this case a weekly solution for the station positions in SINEX format. These individual solutions are available 3 weeks after data be available, and after that, combination centers start to work in the final week solution. So here we have a map with all SIRGAS stations. Not only involving Americas and Caribbean region, but some reference stations around in Atlantic side and Pacific side, which are IGS reference stations. SIRGAS network is composed, has two hierarchy levels. One is the core network, providing the primary link to the global IGS network, which we have here the reference stations in the next slide with dark dots, and the national reference networks, that is a densification, improving the geographic density of the reference stations. So here we have this core network, SIRGAS core network, with IGS reference stations in dark triangles. So you see around here that these stations are define the datum of SIRGAS solutions from the global, that came from global solutions to a region, defining a region datum solution. As combination, for combination strategy, we need to follow these steps here. It means that constraints included in the deliver individual SINEX solutions from processing, from GNSS processing, these constraints are removed, and the individual normal equations from each processing center are solved with respect to the IGS reference frame. The realization of this IGS frame is from the time that this data is being processed. Nowadays, it's IGB 20 since February this year. Coordinates obtained in step 2 for each processing center are compared to each other to identify possible outliers. It means that we check station inconsistencies related to the identification, receiver and antenna module. Antenna eccentricities are checked as well. So before check these large residuals, we investigate what is the problem related to one, for example, one station. And then we need to remove this from this weak solution. The stations with, it means that the station with large residuals, more than 9 millimeters in horizontal components and more than 16 millimeters in up components are removed from normal equations, and we need to repeat steps 2, 3, and 4 until remove all outliers or eliminate all of them. The variances obtained in the final computation of step 2 after remove all outliers are applied to compute scaling factors for relative weighting of the individual solutions. And we have two final combinations, two final solutions. The one to get station positions aligned to IGS reference frame. It means datum realization through IGS weekly coordinates of a selected IGS reference stations are constrained in the a priori positions with 1.1 millimeter. This solution provides the weekly SIRGAS station positions. And another combination computes a loosely constrained weekly solution for station position. It means a priori position for all stations are constrained with 1 meter. This solution is stored for the computation of the multi-year solutions or for national solutions. Here we have the workflow of the steps mentioned in the slide before, in the previous slide. Here, individual weekly solutions from processing centers, the constraints, removing the constraints, then we have free network solutions, and then we start to analyze each solution and check for outliers and eliminating these problems, um, outliers, residuals larger than 9 millimeters and 16 millimeters in height. After that, you apply variance factor from this final solution, and we have a constrained and aligned weekly solution in nowadays with IGS 20, and unconstrained weekly solution. The aligned weekly solution is compared week by week in order to check the inner consistency. Are checked against IGS solutions, that is a global solution. And then here are the external quality check of weekly coordinates that we used to do. So here are some results. In the orange line, we have the quantity of stations of SIRGAS reference frame. Here, time span is from November 2022 until March 2025. We have more than 100 weeks. Here it means the time span of IGS 20. So we start here with 460 stations, and now we have about 420 in operational mode. From that 500 station, around 500 station. In fact, in operation, we have about 420. The RMS of combination is around 1.5 millimeters. This is this dark green line. And the weekly coordinates of SIRGAS stations, it means comparing RMS residuals between weekly SIRGAS solutions. And then we have 1 millimeter in horizontal components here, and around 3 millimeters in vertical up components here in the dark blue. Checking the external consistency of weekly solution, the RMS root mean square of residuals between all IGS stations and a regional solution, weekly solution. We have around 1 millimeter or even less than 1 millimeter for horizontal components, and around 3 to 4 millimeters for vertical components. It is improving a lot in the last weeks, mainly here in 2025. Again, here, checking the external consistency with IGS network, and now applying only IGS reference stations. Then we have 1 millimeter in horizontal components, the residuals, the RMS of residuals, and around 2 or even less, 2 millimeters or even less in vertical, in up components. So here are some issues that I would to report regarding the coordinate time series. Here are some discontinuities, some undesirable situations like discontinuities due to antenna change. In this case, it's even an IGS station, which we have some jumps in time series due to antenna change. Here, mainly in horizontal components. Here we have one discontinuity, here another one. And this is something that we need to avoid for these reference stations. So in the case that you have equipment problems, try to avoid antenna change, because then this causes these problems, these undesirable problems. Another type of discontinuity is due to seismic effects on time series of reference stations. So, for instance, if you have one reference station that suddenly it had an earthquake in this region, then we cannot count anymore with this station as reference. We need to remove as reference in order don't provide problems for weekly solutions. So we have some examples here. And seasonal variation of vertical component in the Amazon region. Here we have only vertical time series of up components. And in this regional, specific in this region, we have year variations of 8 centimeters in up component. So addressing that we need a model to forecast these variations in this region in order to help GNSS processing. So as final remarks, I say that SIRGAS network weekly solutions follow ERS standards and IGS guidelines and apply IGS products in order to provide high precision results. They ensure the SIRGAS reference frame accessibility to the global reference system at the regional and national levels. Model crustal deformation in SIRGAS region is essential for post-seismic and seasonal deformations. And to ensure the long-term stability and reliability of SIRGAS reference frame, it's crucial to reprocess historical GNSS data using a single IGS or RTRF realization over time. These two last items will be subject of the next talk, the Laura's talk. And please don't miss this because it is very important for reference networks. Thank you very much for your attention.